Hi everyone, we are here today for Odyssey APAC Scientific Forum session. We are on the 6th of March. Today we're going to be covering cross-border federated analytics with HUTCH. So it's going to be a joint presentation from A-Star as well as HDR UK. So HDR UK, because of the time zone difference, they're not able to join us physically, but they've done a recording of the HUTCH demo. So they're open to follow-up discussions and collaborations in terms of how we can use HUTCH. So a bit of background to HUTCH. HUTCH is actually a federated analytics tool that HDR UK has developed. It's an open source tool, which they are promoting actively in UK and globally as well. And hopefully through this sharing, we can see more adoption of HUTCH within Odyssey APAC and even Odyssey Global as we go forward. All right, let's go to the next slide. Okay, and a bit of background to why HUTCH, right? Specifically for A-Star and MOH. In October last year, we actually signed an agreement with Singapore's NRF as well as the British National Institute for Health Data Science, HDR UK, as you know, together with our MOH partners. Right? We signed the Memorandum of Understanding to develop data science tools together for health research. And HDR UK, being an active partner here, there are two tools that they're actively promoting. So one is the Carrot Mapper. So the Carrot Mapper, last year we had a session dedicated for that. So essentially it's for OMOP CDM mapping and ETL processes. And they also have something called HUTCH. So HUTCH is the federated analytics tool, which runs with OMOP CDM as the underlying database schema. So these two tools are both open source. And in Singapore, with Trust, we are doing some pilot work as well to explore these tools and how we can expand on them for global cross-border collaborations. Okay, let's go to the next slide. This is a schematic of how HUTCH works. So there are three nodes, as you can see. There's A-Star node on the left-hand side. There's the MOH node, as well as the University of Nottingham, where HDR UK operates, right? Now, each of these nodes will be having their own data, which is already on the OMOP CDM format. And how they're going to be bringing this together is via the HUTCH architecture, where ultimately it goes into TRE, Trusted Research Environment. And because it's on the OMOP CDM, you can do cross-query across sites very effectively. And so this is what we're piloting right now. We have a use case, which I'll share more later. And we also hope to get more support for this use case from the community here to see how this works at scale where we have more and more partners joining this network, right? And we are using the OMOP CDM as a basis for how we are piloting HUTCH with HDR UK. Let's go to the next slide. Thanks. So these are examples of the fields we're looking at. So for a start, we are looking at characterization studies. So here you can see an example of the diagnosis fields from Singapore Cancer Registry. They have been OMOPed. As you can see, the concept IDs are in the second column, and the Odyssey vocabulary is on the fourth column there. So by and large, it's using the NAACCR vocabulary, which is the North American Association of Central Cancer Registry. And you will see some SNOMED and line codes as well. So we've done this mapping together with Singapore's Ministry of Health. Now, the next step is to align this mapping with HDR UK so that we have similar mappings across site before we go on to do the federated analytics. So this is a snapshot of the diagnosis field, which looks at date of diagnosis, where this diagnosis is happening. Right? And the next slide will give you more details about the chemotherapy agents. Right? What are the agents that are being used in terms of first course treatment? Is it a single agent treatment or a multiple agent treatment? Again, you can see that it's using a lot of the NAACCR vocabulary here. Next slide. And then we look at survival status. How are these cancer patients doing in terms of survival? So we'll do some simple survival analysis as well. Okay, next slide. Yeah, so overall, it's meant to be a characterization study, looking into descriptive stats, looking at the chemotherapy agents, as well as cancer survival of these patients. But we're taking a federated approach across Singapore and UK for a start. And this is where we'd like to see more support coming from this community. The next slide is actually a call for more collaborations. So we are looking for more collaborators to explore these two. And that is also why I'm setting this as a basis before we go into the HUTCH tool demo, so that you can start relating to how potentially some use cases that you have on your end, we could be using it for this oncology use case using HUTCH as the underlying technology. Okay, next slide. Okay, so here is the demo videos that HDR UK has prepared. There are two links. So one is coming from Phil, who is the director for HDR UK, and he's kindly recorded this for us. And the second one is more towards the HUTCH itself. It tells you how HUTCH operates in terms of cohort discovery. So in total, it runs for about 30 minutes. So we will run the demo video for you to find out more about HUTCH. Before that, any questions from the audience here? Okay, looks all good. Yeah, we'll take more questions after we've seen the video as well. Thanks, Erwin. So we can play the video.
Just a moment, I'm switching the screen.
Okay.
I cannot hear the sounds of the video. I think you have to, share.
Yeah, I think the audio is not passing through.
Fine.
Erwin, you need to stop sharing, and you need to share again with the option to include sound when you share.
Oh, okay. It's just a moment. Oh, okay. Sure. Thank you, Song.
No problem.
Include song.
Thank you for the opportunity to talk to you once again. So my name's Phil Quinlan. I'm the Director of Health Informatics at the School of Medicine at the University of Nottingham. My role spans both the university but also into Nottingham University Hospital's NHS Trust. So I kind of sit between the two via what we call our Biomedical Research Centre. So it's our translational research programme. And part of that role, I then get involved in some exciting national programs. And today, I'm going to give you a bit of information about what we're doing along Federated Analytics and so what I've called our Federated Journey. I'm more than happy, obviously, to have follow-up conversations with anybody that's interested to know more. All the code we've developed, as with Carrot, is all open source as well, so you can find out more about it. So first of all, what do we mean by federated analytics? So in its most simple term, this is the process of analyzing data that sits in multiple different environments. Usually this means the data cannot come together because it might be sensitive, as in people might not want to share it, or it can sometimes be said that the data is too large to move. And in the UK, we've had a significant move to trusted research environments where the data is locked down in a very secure environment and the researcher goes into that environment. But the risk of these TREs being created is that you have these silos of data that can't talk to each other. So what tends to happen when you try and do this, as in a federated analytics way, is you go into each environment, you do your analysis in that environment, take out the results, and then you do some sort of meta-analysis. So this is part of the program from Health Data Research UK. I'll explain a little bit more about what HDR UK is doing in the space a bit later. But obviously where this becomes really interesting is when we try and do international research. So how do we do analysis between the UK and Singapore, for example, without having to send the data to each other? So the data stays where it is, but we can still do federated analytics. In the UK, one of these national programs that came out at the end of COVID, and this has only recently been published actually, so it's only recently that the Coalesce study that has been made available in the journals, and this was kind of the tagline was this was the first UK whole population analysis, so on 65 million people and across 4 TREs. So you can see there's in our healthcare system, it's a devolved issue. So there's NHS England that hold the data from England, where there's 58.9 million, but there's a separate environment for Scotland, Northern Ireland, and Wales. So there's 4 national TREs. And this data analysis was done across these 4 TREs, and it was achieved. So I think we need to acknowledge that federated analytics is not new. It's not something that's never been done before. It can be done, and it can be done at scale, but it's a slow and it's hard work. And so when you actually look at the challenges that this study have called out, one in particular was what they call the difficulties in data harmonization. So the fact that every nation records data differently, and also how do you write code that is compatible between these 4 different environments, and obviously at 4 very different scales. So if you've written code that can analyze data of 1.9 million people, for example, in Northern Ireland, how do you know that that's actually going to run when you try and run that on 58.9 million people when you bring it over to the NHS England environment? And of course, the challenge is that the coding environments in each one of these is different, so it doesn't have the same types of tools and sort of programming languages available. And so if we look at the current situation, if you're a researcher and you're wanting to do your analysis, you've got 3 different TREs that you're going to go into. The challenge really here is that you have to write a script for each one. It might be that one TRE offers you Python, another offers you R, another offers you SPSS, but then also there's different databases underneath it. So in one TRE it might be Postgres, and another it might be SQL Server, and another it might just be CSV files. So you've got real variance that happens between TREs. So if you're a researcher there doing your analysis across 3 TREs, you're most likely going to have to write code for each one individually. Not to add that the way the UK TREs work is you do your analysis within that TRE, but when you want to take anything out, it goes through a disclosure control process. And essentially what that's trying to do is to establish if there's any reason that that data cannot be pulled out. So is there anything identifiable in there? Each one of those disclosure controls can be different. So you've got 3 different disclosure control processes and 3 different ways that you're going to write your analysis to run on the multiple different environments. So the consequences of this is really everything I've said, but then also time is lost. It becomes hard to do this. It becomes slow to do this. And you can see that from the Coalesce study. That was a study undertaken on COVID or related to COVID and the pandemic. And it's only recently been published in the last 6 months. So these things take time. They're not fast. They are slow. And that's the consequence of the current situation. So one way to try and get around this is to have and bring in a federated analytics or federated learning platform. What they tend to do is install software in each environment. So the API is standardized, and they say, actually, our API requires Python to be present, and we've got to have Postgres installed. Now, for the advantage for the researcher in this situation, they can now access one platform. They don't have to access multiple. They can just access one single website, and they can do federated analytics, federated learning across that. Then also the other challenge for the TREs is quite often this requires some sort of bypassing of the normal disclosure control process. So it's not that disclosure control would not be done. It's just that it might bypass what that normal process would be. And so the consequences really on this approach is for the researcher, it's a massively positive component, but actually for TREs, this becomes quite a challenge. So it requires standardization of a database platform. They might not have that. It requires the installation of software, but it does give that advantage. So yes, what we've achieved for the researcher is good, but what we've achieved for the TRE is not so good, because they have to install that platform, convert their data to the standard, and have all that in there as a full stack. That's not ideal. So if you want to be a part of multiple federated networks, you're not going to install multiple versions of all these different software stacks, different tooling, and different databases just to satisfy the needs of each federated platform. So introducing something called ㅍ UK. This was a program of work. We've had version or stage 1 of the funding so far, which created some pilot projects. They called them sprints. So during 2023, so last year, we had a 9-month sprint. The program is what we call cross-council. So we have research councils that fund in different areas, for example, the Medical Research Council or the Engineering and Physical Sciences Research Council. This was a program funded by multiple of them, because what they wanted to make sure, well, this wasn't just solving the problem in health, but how do we bring analytics across multiple different types of trusted research environments across multiple different domains. The URL's on there if you want to have and find out more. The 2 ones that I'm going to talk to you about, one was led by University of Manchester, that's with Carol Goebel, and this was how we can use ㅍCross and Federated Analytics. That's where the HUTCH code base also sits. But there's another one led by Swansea, University of Swansea, from their search team, which is around how do you create an illusion of a network, a single network of TREs. First one called Terrifics, second one called Teleport. The key strengths here is we're really trying to make sure we can do analysis across multiple different environments. That's the key thing we need to understand about this. So Teleport was the name of the project led from the University of Swansea. This is Simon Thompson's work. And really what this was trying to do was 2 things. But one component of this was to utilize Trino. So if you are logged into one particular TRE, you've got your script and it can have Python behind the scenes. It allows you to have this federated mesh across the different TREs. So by logging into one, going through one's disclosure control process, it gives you a mechanism to have access to a whole network of TREs. So Trino does the federated databasing and be able to access different databases in different locations, but they also had some software and networking options there. So each TRE appeared as if it was on one network, as if it was all together. So the major changes here is we're abstracting that database layer. So from a researcher's point of view, they interact with a Polystore, Trino, and this complexity or the differences that are in each location is hidden to the researcher. So they can write code once, they write their script, it runs on Python, and they can access multiple TREs, and their code can work with TREs that have different databases. This also creates that interoperable mesh that I talked about between the TREs. Therefore, the researcher gets a benefit. All the TREs do need to come together to agree the governance models and agree what that disclosure control process will be. One downside, though, is that the researcher still is dependent on the TREs that they log into and the tools that TRE offers. So in this situation, the researcher logs in to this TRE, they have to use Python. If they logged into different TRE, they would have to use R. So this layer hasn't been abstracted yet. It was the data layer and the network layer that's been abstracted, and that's what Teleport was seeking to deliver. Terrifics, on the other hand, was a program of work to abstract that computational layer. So we've got our researcher, they package something up, they package the analysis they want to run in something called the ㅍCross, which is really just a zip file. But if you Google that, you'll get a list of all the examples that they've used before. That goes to a submission layer. So it's held there. That kind of could be on the public web, or it could be within a TRE. Within each TRE, there's some software that we call the TRE controller. That dials out, goes to the submission layer, gets the package that it needs to run, pulls that down, and this is where then HUTCH takes that crate, the ㅍCross, unpacks it, grabs the workflow, and then we can use a workflow engine to actually run that. So we're using the CWL tool, for example, to run our CWL workflows. We did mandate as part of Terrifics, though, that everybody has to have the same type of database, just to make this easier to actually get a workflow in and to have that code running. But because we're then utilizing workflows, it doesn't matter what environment the TRE actually has. It doesn't matter if that code is in Python or R. It can all be self-contained in a container that can go down and be run within that environment. So the major changes in Terrifics as compared to Teleport and Terrifics, we're trying to make sure that the TRE can, from one installation, be able to support multiple workflows. And from the researcher's point of view, they write a workflow, and that can simply run in each TRE. The really important thing that the RO Crate also does is capture all the provenance information about what's available, and what creates the provenance information for everything that's been run, what it did, what's the data it ran on, what's the workflow it ran. So there's a whole audit log there that can be available to other people to have a look at. So this is a good step forward as well. This is one of the two sprints, the 9-month projects. But it also means that we still maintain disclosure control in each location. We have a submission layer, and we've got these controllers that do the communication. So very much compatible with the existing way that TREs operate. So bringing those two together, Teleport demonstrated the technical ability to network TREs and to provide that single pane of glass across multiple databases. Terrifics demonstrated how you can have a single computational layer that can receive a workflow, can run that, and take that through the necessary disclosure control process. So if we go back to the Coalesce study and think about the challenges that they talked about, challenging to write code that's 100% compatible with each of the nation's TRE, what we've got between the Teleport and the Terrifics project is a technical solution to that problem. If you Google ㅍ UK Teleport and Google ㅍ UK Terrifics, you'll then be able to get more information. All the documentation is available on Zenodo if you want to have a look at the technical implementations, and they can also contain the links to the GitHub repos if you want to have a look more. As with Carrot, as we've mentioned before, we're really open and hope people want to come and help co-develop these tools with us. So I couldn't be at an Odyssey meeting without talking about OMOP. So one of the challenges, obviously, that they mentioned in the Coalesce study was that each nation then records data differently. And what we found in the UK is that many data controllers really do want to be standardized, but they don't necessarily have the right expertise. And they need a different way to try and curate that data in a federated network. You may well have heard the presentation from Esmond before around Carrot, but just very, very quickly, the whole purpose of Carrot is to help data controllers to standardize their data to OMOP. So they've got their data in their secure environment. They do an extract using White Rabbit. That metadata comes out to our infrastructure for this part of the CodeConnect project. So we do our mapping here in the Carrot tool, but then that file comes back down and the data can be OMOP'd. Now, what's interesting about this is just a Python process that runs on the data, and this all then connects up to the HDR gateway. What we're looking at is how can we actually make this part run as a workflow on HUTCH. So we can do on-the-fly, on-demand curation of data to OMOP, so that we can, first workflow that comes round would be the workflow required in order to convert the data. Second workflow that would come round would be the one to actually analyze the data. Okay, so if we now go into our work with Health Data Research UK. So what is Health Data Research UK? If you've not heard about it, it's the National Institute for Health Data Science. Their catchphrase is always talking about driving data analysis, pace and scale. It's currently year 2 of a 5-year program. There's their website if you want to take a look and find out a little bit more. There's 2 major components to this program. One of the driver projects, which are really there to try and push the boundaries in terms of how we can use data and how we can analyze it. But there's also the infrastructure layer that's there to try and push the boundaries to show what is possible, which might not have been possible before. I'm part of the Federated Analytics program. It's part of what they call Pillar 1, which is a technical ecosystem. I co-lead that with Professor Carol Goebel from Manchester. What we're really trying to do there in the HDR program is to assemble the best tools rather than always thinking about building new. So when I was talking earlier about the RO crates, that's technology that's been used before. When I was talking about the workflow engines and the workflow standards, that's already been used before, that's already been done before, but we're bringing it really closely together to work. So we'd call it assembly of tools rather than building new tools. We really want to work closely with industry. We believe there's a lot of tools out there that we can just bring in from that point of view as well. And importantly, although we talk about federated analytics and the program is called Federated Analytics, we don't actually do federated analytics. We are trying to build the infrastructure to enable others to do federated analytics, and that's the key program that we're trying to do here. So if we look at HDR's 20-year vision, this is all about how do we do population level research, so up at 67 million people, but then across multiple data sets, really bringing in the detailed data sets, so not just the high level incidence of disease, but everything also there as well, so it can really understand the data about people and understand some of the causes of disease. We sit very closely under the theme, which is called Accelerate Trustworthy Use of Data. And the things that are really important to me there are the democratized access with no privileged or exclusive access arrangements. I think that's a really key thing that HDR is trying to do, is to enable research at that type of scale. So how do we align up with the HDR UK's strategy? So in their strategy, they talk about that, the democratized access with no privileged or exclusive access arrangements, as I said before. For us, that really is a success criteria for federated analytics. They're looking at doing national data capability over regional and structured data and unstructured, but also leveraging the power of multi-source data. To us, that is federation, and we're trying to understand the technical mechanisms that are required in order to make that possible. They're talking about the embedding of reproducible data pipelines. That's exactly what we're doing in terms of workflows and the workflow engines. And they obviously want open source and interoperable software. And that's where our approach to assembly of tools becomes really important. So what are we trying to do? How do we combine both of these? So as I mentioned before, Teleport can be that abstract of the database layer and also the network layer. And Terrifics brings in the abstract of the computational layer. So you can see here from a researcher's point of view, they can interact with one layer, they get the standardized compute, but they also get access to multiple TREs via a standardized mechanism to that data layer. This is a big task for us to get this over the line. We're trying to make sure everything we do has the reinforcement of audit, transparency, and reproducibility. But we recognize this is also a change management process. So we have a PhD in Manchester based on this, and we've also got a PhD in Nottingham looking at how do we understand the suitability of different types of federated learning. With that, I will end. Thank you very much for your time. I hope that was a useful insight to what we're doing in the Federated Analytics program, but also how we're bringing Carrot into that mechanism. Thanks very much. Hope to see you soon, and please get into contact if you have any questions.
Thanks, Erwin. So that was the introduction by Phil on HDR UK's strategy on federated analytics. He gave some quick introduction to HUTCH. The second one is about 10 minutes. It gives you a bit more technical details. For those of us who are more technically oriented, we want to know what's the underlying mechanism behind HUTCH. So that one gives you more context. Yeah. Let's go to the second YouTube.
This video is a demonstration of using HUTCH and associated open source tools to perform cohort discovery, servicing a query from the BC ㅍCross platform. HUTCH was developed as part of the Terrifics project, TRE-FX. The HUTCH agent is an implementation of the Terrifics executing agent, which lives in the workflow executor layer. It's responsible for providing a bidirectional RO-Crate interface for executing workflows. You can see here how the HUTCH agent provides an API for interacting with the Terrifics controller layer. When a job is submitted, it fetches a referenced RO-Crate from an intermediary store and validates that the crate meets the Terrifics 5safes RO-Crate profile and that the crate is in the appropriate state to trigger a workflow execution. Assuming the crate is valid, the HUTCH agent prepares to execute the job. It will fetch a workflow RO-Crate from an air-gapped source and produce a configuration for WIFEX, the workflow execution service, to run that workflow. With the inputs provided in the 5safes crate and the project's dataset connection details provided by the TRE controller. WIFEX is then started with the configuration and executes the workflow. It will pull any required container images from an air-gapped source, and then run the workflow steps against the dataset. WIFEX outputs a workflow run RO crate describing the provenance of the workflow's execution. The HUTCH agent, upon receiving this output, places it in the intermediary store and initiates a request for egress. This is subject to the TRE's disclosure controls, as configured via the TRIFIX controller layer. If egress approval is granted, HUTCH incorporates the outputs into the 5safes RO crate and returns the updated output version to the intermediary store to be returned to the user. In this demonstration, we will follow the process I've just described for a cohort discovery query from ㅍCross. To facilitate the complete end-to-end journey, we will use the HUTCH controller, a lightweight implementation of the TRIFIX controller layer specifically built for this use case, and ㅍCross bridge, which, as its name suggests, serves a bridge between the ㅍCross REST API and the 5safes RO crate and the HUTCH API. In this diagram, you can see that ㅍCross is effectively serving as a submission layer by which users can send jobs to the TRE. ㅍCross bridge and the HUTCH controller together form the controller layer, where ㅍCross bridge handles bidirectional, i.e. input and output, interactions with ㅍCross via outbound HTTP requests only, and the HUTCH controller does the same for the HUTCH agent. Everything in the workflow executor layer, here labeled HUTCH for simplicity, is as I described earlier. Note that while this supports running in an air-gapped environment across distributed infrastructure, for the purposes of this demo, we are running everything inside the TRE on a single virtual machine with internet access. For this demo, the HUTCH controller simply performs a pass-through automatic approval for disclosure control. At this point, I'd like to take the time to look briefly at the 5safes RO crate profile. In this demonstration, the ㅍCross bridge generates that crate for the ㅍCross query it receives. And while we can inspect the input crate it generates as well as the output crate that HUTCH sends back, there isn't really time to explore it during the workflow execution. So let's take a look now. The 5safes RO crate profile specification can be found on the TRIFIX website. The RO crate contains metadata surrounding checks performed in the process thus far, as well as information about the project and person who submitted the job. It also contains either a workflow directly or references a publicly available workflow, such as one available on Workflow Hub. Finally, it contains the inputs to that workflow for a given submission. And here we have a previously generated input crate for an ㅍCross query. If we look at the crate's metadata file, you can see its conformance to the RO crate profile, including the 5safes crate profile that we just discussed. It also references a workflow available publicly on Workflow Hub and an input file for that workflow for this particular job. The metadata also contains mentions and details of any checks that have been passed in the process so far, as well as information on the project that this job was requested for and the organization and even individual who requested it. If we look at the input file referenced, you can see that it is an ㅍCross availability query payload in its native form as raw JSON received from the ㅍCross REST API. It contains the query information for patients matching a condition for a given OMOP code. Here on Workflow Hub, you can see the workflow we will be running. It executes an open source command line tool we developed called ㅍCross OMOP Worker by pulling a container image for that tool and then executing it with the provided inputs. We will be using this instance of Minio as our intermediary store, and we'll revisit this bucket to see the files stored during the process. In production, you might use different buckets or path prefixes for different stages of the process, but for this demo, we'll pretty much just be putting everything into this bucket. Here we have our demo VM. Most of the stack in here is running in Docker, bootstrapped using Docker Compose. You can see Minio, the intermediary store, and RabbitMQ, which HUTCH uses to manage the jobs it's executing. We're also running the ㅍCross bridge and the HUTCH controller. The HUTCH agent and Wifex do not run containerized at this time. The HUTCH agent is running on this machine as a systemd service. We are in Ubuntu. And Wifex is executed on demand by the HUTCH agent. The dataset is some synthetic OMOP data stored remotely in a Postgres database. Let's connect to our running services and tell their logs so we can see what happens when we send the ㅍCross query. We'll do the ㅍCross bridge at the top. The HUTCH controller in the middle, and the HUTCH agent at the bottom. You can see already that the ㅍCross bridge is regularly polling ㅍCross's API to see if there are any jobs waiting. The other two services are just listening for HTTP requests. Now that we're tailing logs for everything, we can submit a query. Here's the BC ㅍCross interface. I'm going to create a new query, and I'm going to send it to two different collections. You can imagine that these are different data sets in different TREs, but in this case, however, they're both backed by the same data set. One is running BC Link, and the other is our HUTCH VM. For the query against this dataset, we'll just look for patients with a breathing-related condition, since I know this dataset will have some. So now that we've sent that query to both of our targets, we can look at the HUTCH environment. You can see there that the ㅍCross bridge accepted a job, and if we look at HUTCH's logs, we can see that it too received a jobs request that it has accepted. It's extracted the crate it received and sent status reports to the TRE controller. The HUTCH controller has received those at its update status for TRE endpoint. Meanwhile, the HUTCH agent has downloaded a workflow and unpacked it, and then triggered Wifex, the workflow execution service, to run the workflow. In the meantime, the ㅍCross bridge is back to polling the ㅍCross API to see if there are any more jobs. The HUTCH controller is just listening for status updates. Now, Wifex has just completed the job, and so HUTCH will unpack the outputs that it finds and send status updates to the TRE controller. It'll notify it of the intent to egress those outputs. And here we can see that the controller has fully approved them very quickly. HUTCH receives that approval confirmation and then sends a complete status report, at which point it will have uploaded the final output crate. If we look up at the ㅍCross logs just a little way up, we should find that it has found the final crate and downloaded it, unpacking the result to return to ㅍCross. And there it's completed handling that complete job. If we go back to the ㅍCross interface, you can see that both environments have completed the query and returned the same results, BC Link and HUTCH. If we return to our intermediary store, you can see what it was used for during the process. The first zip file here with the ID is the input RO crate generated by ㅍCross bridge. The final result crate is the output RO crate the last thing returned by HUTCH that contains the results. All the other files in here are what the HUTCH agent uploaded for egress inspection. They're outputs from the workflow execution, and they could be inspected by any necessary disclosure process, automated or manual or a combination of the two. Let's download the crates and have a quick look. So let's explore the zip files that we downloaded. Just going to extract this one so that we get the zip files inside. Here's our input crate with the ID. You should see that this looks basically no different to the one we explored earlier. The query, however, should be for a different OMOP code. And you'll see the timestamps in the metadata should differ as well. If we look at the output crate, you can see it contains quite a bit more. It still has all the original information, including that same query file. And obviously it has a RO crate metadata file. But the metadata file has been expanded. So it now includes additional checks, for example, such as completing download of a workflow and disclosure approval. And it has outputs as well. If we look at the outputs, you can see this actually includes the entire workflow run RO crate from YFX with its own crate metadata. And you can see that we have the output from that run, which is a JSON response for our quest. And there's our query count that we saw in the RQuest UI. I hope you've enjoyed this demo of cohort discovery using HUTCH. Everything demonstrated here, except BCRQuest, is an open source tool. Most of them are available on GitHub. This is the HUTCH repository, which includes the HUTCH agent and the HUTCH controller. The YFX Workflow Execution Service repository is here. And this RQuest Tools repository contains the RQuest Bridge application and also the code for the OMOP worker, which runs the query as triggered by the workflow. Finally, this page, available at this URL, contains links related to our work in Federated Analytics.
All right, that was the technical demo. Thanks, Erwin, for running these videos for us. Any quick questions from the community here?
Even though I do not understand the HUTCH system entirely, but if Singapore involves in this part, that means that so you're gonna install this TRE system and with the HUTCH system within your environment. Is that right?
That's right. That's right. Yeah, we're setting up HUTCH in our environment and doing this with UK to show cross-border analytic capabilities. Yeah.
Awesome. But I think the current HUTCH system, can operate only the very simple queries for AMOP CDM, just to extract some of the, values based on the very simple logics. So is there any, a plan to implement more, complex RDC study pipelines, such as ADALA's core definition system or other PLE core method packages or PLP packages?
Yeah, it is in the pipeline. That's why this collaboration, we're studying it as a simple characterization study, not going in depth into advanced analytics. And this is also where HDR UK wants to work closely with Odyssey, whether it's running Atlas, with HUTCH or other of our strategist packages. So they are very interested to work with us. and we can collaborate with them to build some of these tools together.
Awesome, thanks.
Yeah. Any other thoughts, questions? Yeah, so it would be really nice if we could get some more support from the community, right? Just to try out how HUTCH would work. If we have another TRE set up on your end for this oncology use case, I think it also strengthens the findings, right, about some of the strengths and the weaknesses of HUTCH. Like what Chen was saying, perhaps at this point with more aggregated summary stats level, right? So these are things we can feedback. But I believe in the long run, it will help Odyssey as we move towards network studies increasingly. Yeah. Yes, Cynthia, your hand raised. Yeah. Cynthia, you may be on mute. Yeah. Yeah.
Yes. Asia Golazar, who is the lead for the Odyssey Oncology Groups, is going to be running a study-a-thon on non-small cell lung cancer. And I think it would be, I'm just so impressed that you have already OMOP'd the Singapore Cancer Registry. So I think you could be a really valuable additional database for that study. So do you know how to get in touch with her? I can let you know how to reach her. And then the second thing I just wanted to let you know is that the vocabulary group recently released an updated vocabulary, and I noticed that they had done a lot of work on mapping different cancer regimens. You know, because there's some of them are so complex and they all have these acronyms and there's multiple drugs and pretty complex timing that the different drugs are given. So I just wanted to highlight that so that any data that you have, you may want to update your ETL with the new vocabulary. And I believe Claire Blacketer has a simple program that allows you to do that pretty simply if all you're doing is just updating the ETL.
Okay. Yeah, definitely. Feel free to connect with Asia. I think it would be nice to bring in the oncology working group support here as well, since it's dealing with oncology study. And yes, the vocabulary will be helpful as well as we maintain this for these cancer registry data sets. Yeah.
I just also want to let you know that I'm in Singapore at I'm staying at Kent and through May, so I would really love to have an opportunity to meet you.
Sure.
Over.
I think Evelyn Go also saying about your interest in wanting to do something with trust. So
Trust.
Yeah.
And HSA would like, because HSA could be a very it's a whatever, it's part of, it's like a statutory board under MOH. They have a lot of use cases. And so if we can demonstrate some things with the platform, I think it will build some momentum in support for the work that you do.
Okay.
Over.
All right. Thanks, Cynthia. Alim, you have a hand raised. Yeah.
Yeah, I just have a few things. Like, I learned quite a bit from this presentation. We are working along very similar lines of, we have 3 projects, but which are covering a lot of things which are touched in this work. One is the TREs, and we said we have the problem of siloed TREs. And yeah, the presentation talks very well about how they can be networked through teleport, which sounded very interesting to me. I'll put it in front of the project team. I'm just saying, yeah, that's a very good thing. And the other thing is, like, we are working on another project called Federated Learning. It is all about doing analytics, like machine learning, without sharing the data. Of course, it is a very high level thing. We did some demos, but we are, let's say, at a very, very early stage. And I felt that OMOP could be a thing which could face, like, say, how the data will be standardized or harmonized to do the analytics. So yeah, that's the only 2 observations I wanted to talk about. But yeah, very impressed. Yeah.
Thanks, Alim. Yeah, I agree. I think federated ML is something of interest as well, right? I think over time we can show the capability of using OMOP CDM, right, as the base for federated ML. Is a lot of potential as well in the Odyssey work that we.
Yeah, thank you.
Thanks. Any other questions or thoughts? We have about 7 more minutes remaining.
Hey, Mukesh Song here.
Yeah.
Quick question on the cross-border concept you're currently pursuing with HDR UK, right? So I understand the HUTCH layer. I understand the teleport layer, if I remember it correctly. So would there be a central platform where either HDR UK researchers or the Singapore researchers would access, and that would trigger the HUTCH layers and the teleport layers in Singapore and in UK? So essentially, I'm interested in my question is there going to be a central place where people either from HDR UK or the people who are participating in this cross-border analytics project would log into and be able to query whatever simple counts or whatever that is currently supported by the analytics platform and get results at a central place instead of this being, federated, right? So I'm just trying to understand, when you say cross-border, is it that you have individual installations of HUTCH all separately and you're collecting results like we traditionally do within the Odyssey community? Or is there a central platform, as in a central URL or whatever, that you would log into and trigger those queries to go to these nodes and get those results back? Does my question make sense?
Yeah. I think so fundamentally, data still resides within the two countries. So the concept
Of course, yep.
There, the data is not being cross-shared, but there will be a master controller layer. So this is where the partners will decide where this master controller resides, because that's going to give instruction to the UK node as well as the Singapore node. In the example that I showed about the oncology one with MOH, the master controller sits in Singapore. So it's giving the instructions to the two nodes. Yeah. So the concept is there, like how we approach Odyssey, we run it behind our firewalls, or here TREs, right? But because you need to operate this federated system, you will need a master controller. So it's up to us to define where you want to situate this master controller. In the case of this oncology use case, the master controller sits with MOH Trust. Yeah.
Okay. And that's triggering the query to go to UK as well, correct?
Yep.
Okay. That's interesting. Very interesting. Okay. Thank you.
Yeah.
Thanks.
So to clarify that, like, it also sits inside the TRE, is it?
Yes, it will be inside the TRE.
Yeah. Okay, thank you.
Okay. Any other questions? Okay. It looks all good for today. Yeah. So
Mukesh, in terms of post-call, right? These materials will be available to the community to be shared, right? Okay, excellent.
Yes, we'll share. So the links to the two YouTube URLs we saw is in the slides.
Right.
And so you could refer to that. And of course, if you have interest in joining this oncology project use case, feel free to drop me a note, and I'll be happy to extend the different countries and partners into this project as well. Yeah.
If you can share the slides over, we're happy to get it uploaded on Odyssey so that everybody who missed the call today live can have a look at it.
Yeah, we'll send it after the call to you. Thanks. Yeah. Okay. Right then, I think great session today. Happy to see the interest from the community, and let's follow up in 2 weeks' time for the APAC community call. Okay, thanks everyone.